introduce you the members of Group 14. It's almost scared me. Nah, never mind. Let's get started. Aha, objective. There are two objectives here. First, to apply the understanding of the process of crystallization in food to everyday life. Second, to understand the importance of the application of crystallization in food products. Let's move to the next. Introduction. Do you know what is crystallization? Crystallization is defined as a process by which a chemical is converted from a liquid solution into a solid crystalline state. Do you know which part in food processing involves crystallization? Crystallization acts as both a separation and purification step during food processing. How do you think the crystallization process occurs? Let us ask Miss Angela about this. Hello, Miss Angela.
Hello, Jen.
Can you share to us how does the crystallization process occur?
Yes, sure. Hello everyone, I'm Angela. I'm the leader of Group 14. Today, I will be the representative for this topic. Crystallization process consists of two major events. The first major event is nucleation. Nucleation occurs when molecules gather together in clusters in a defined manner. Clusters need to be stable under current experimental conditions to reach the critical cluster size, or they will redissolve. It is this point in the crystallization process that defines the crystal structure. Next is crystal growth. Crystal growth happens when the nuclei that have successfully achieved the critical cluster size begin to increase in size. Crystal growth is a dynamic process with a term precipitating from solution and becoming redissolved. Supersaturation and supercooling are two of the most common driving forces behind crystal formation. This is the example of graph that shows the crystal growth rate.
Wow, that's so amazing! Thank you, Angela, for the sharing.
You're welcome, Jen.
Next, I would like to invite Miss Aini to give some point about the major factors that affect crystallization.
Thank you, Jen. Hello everyone, I am Nuraqilah. There are 5 major factors that could affect the crystallization process. The first factor is moisture. High humidity influences the initiation of crystal formation. Next factor is temperature. When the temperature increases the rate of evaporation, it will automatically speeding up the rate of growth. In different temperature, the amount of crystals produced also different. After that is solubility, which is the first one is compounds tend to be more soluble in hot liquids than they are in cold liquids. And the second one is if a saturated hot solution can cool, the solute is no longer soluble in the solvent and forms crystal of pure compound. The first one, pH can affect the conformation, activity, electrostatic interactions, and solubility of protein in the solution. And the second one, to success in crystallizing proteins, needs to manipulate the pH. Did you know the presence of other substances may affect crystallization? Actually, some products can be added to prevent the formation and growth of crystal, such as egg white, cream, and butter. The agent coat the crystal and prevent the growth of large crystals.
Hello everyone, I'm Wafa. Today, I will share to all of you why it is important to know the characteristics and quality of the crystals in different food. Many factors can influence crystallization in food, so controlling the crystallization is important whether you want to feel the food gritty or smooth in your mouth. Did you know? The fact that sugar solidifies into crystals is extremely important in candy making. I think I'm gonna take candies for an example. There are two categories of candies, which are crystalline and non-crystalline. Crystalline is the candies that contain crystals in their finished form, such as fudge and fondant. While non-crystalline candies do not contain crystals, such as lollipops, toffee, and caramels. For your information, recipe ingredients and procedures for non-crystalline candies are specifically designed to prevent the formation of sugar crystals because they give the resulting candy a grainy texture. When making a caramel or candies, we want a smooth texture and not a grainy one. Large sugar crystals will cause a grainy texture in confectionery products. And if you want to make a candy, like fudge, you need a creamy texture. This creamy texture comes from the formation of tiny sugar crystals.
Wow, such an interesting fact. Thank you for your sharing, Miss Wafa. I hope I can apply the crystallization process to make my own candy.
Yes, of course you can, Jane.
Let us teach you how to make a candy by your own.
Interesting.
Oh, hey Verdynna, Lauren, and Nelly.
Sure, let's make some candies.
Would you like to start, Miss Verdynna?
Hi everyone, I'm Verdynna. To make a candy, we need to know its main ingredient. Do you know what is it? Yes, it is a sugar. Do you know which type of sugar are used? Mainly sucrose from sugar beets or sugar cane is the major constituent of most candies. There are two types of basic ingredient involved in candy processing. The other sweeteners that used in candy manufacture are corn syrup, corn sugar, honey, molasses, maple sugar, and non-caloric sweeteners. The fudge are sugar, butter, and milk, while the additional are chocolate, caramel, fruits, nuts, and more. The fondant are sugar, water, corn syrup. For sculpting and shaping, gelatin or glycerin is added.
Now, let's make some candies. Step 1. Prepare the sugar solution. Prepare crystalline sugar, sucrose, such as glucose or corn syrup, invert sugars, as its main ingredient. All pots and utensils should be spotless and dry. Then, dissolve the sugar in water and optionally mix with other ingredients to create a sugar solution. The sugar and water ingredients are put into a large pot so boiled sugar does not overflow and place over medium heat. Stir the mixture continuously until the sugar has been dissolved. Note: sugars have a strong affinity to water. Sucrose is the second most soluble sugar, and both parts can easily dissolve in one part of water called a sugar solution, forming temporary but strong bonds to nearby water molecules.
Step 2. Boil the sugar solution into a concentrated sugar syrup. High heat dissolve the sugar, evaporates the water, and break the sugar molecules apart. It causes the sugar syrup to get hotter and denser, resulting in the sugar syrup in concentrated sugar molecule. The sugar molecules are tightly concentrated in the water, reaching a supersaturation state while at the same time being more unstable. Any unnecessary jarring, stirring, or bumping of the pot during the boiling phase will cause the unorganized sugar molecules to recrystallize or form an ordered sugar crystalline structure, ruining the whole batch. As the sugar solution continues to heat, the sugar molecules move faster and further apart, allowing the solution to dissolve more and more sugar molecules until it boils. Here, the solution of sugar is transformed into a clear, syrupy substance and called a sugar syrup. Once the solution boils, a lot of water molecules are released into the air, concentrating the solution as sugar syrup and increasing its boiling point. In general, a solid such as sugar dissolved in a liquid makes it more difficult for liquid molecules to escape. As a result, the solution must be hotter in order for the liquid molecules to get away at the same rate and the boiling point to rise. Step 3 and 4. Cooling and beating. This is optional. Whether the sugar syrup is cool or stirred during or after cooking is determined by the type of candy that is made. Many non-crystalline candies are poured out of the pan immediately after cooking. They harden quickly because they are made from highly dehydrated sugar syrups, and any agitation or stirring will cause unwanted crystallization. For example, caramels and hard candy, such as lollipops. They are poured directly into the molds or pans and left to cool and pre-refrigerate the concentrated sugar syrup. When boiling stops, the rate at which the solution is cooled depends on the type of candy being made.
The higher the temperature of the sugar syrup, the slower the rate of crystallization, which is faster at a lower temperature. If you cool quickly after boiling at a known heat, the candy forms like a crystalline or brittle type of candy, like a rock candy. At a slightly slower cooling after boiling at the same temperature, the candy forms a non-crystalline structure known as a taffy or caramel. Lastly, if you add a gelatin, starch, pectin, or gum to the boiling mixture, the sugar will gel and make products like jelly beans, Turkish delight, and licorices.
Thank you guys for the sharing and tips.
Hello everyone, I'm Nuraqilah. I would like to add some point about the precaution during doing the homemade candies. The precaution number 1 is make sure to wet the sugar and measure the water accurately. Number 2, make sure to use wood spoon or spatula. Avoid to use iron spoon to mix water and sugar together. It is because the solution will get much hotter and stickier than boiling water. Number 3 is keep stirring the solution as it boils to avoid the solution burn. Number 4, run cold water on the skin if the solution gets on the skin to avoid skin burns. And the number 5, use glass jar to put the solution after it boils. Do not use plastic glass to avoid the plastic melts when the hot solution pour.
Thanks to you too, Miss Akila.
I think that's all from us today. Thank you everyone.
Bye-bye. Stay safe, everyone.